6, right? So in order to exponentiate, we're going to do 6 raised to the log base 6 of 2x minus 1, and then 6 to the negative first power. When we do that, if you recall from 7.4, our 6 raised to the log base 6 power cancel, and then all we're left with is that 2x minus 1. And then 6 to the negative first power, if you guys recall, negative exponents tell me to flip. So this should be 1 over 6 to the first power, which is just 1/6. And this is something we know how to solve, right? Now that we've gotten rid of all the logs and the exponents, all we have to do is add 1 to both sides. And then we're going to divide by 2. And when we do that, remember we have to keep the 7/6, change to multiplication, flip the fraction to get x equals 7 over 12. I know I solved for x really fast, but that big step I wanted to address was the exponentiating there, right? Whenever we have a logarithmic expression that's split between two expressions, we need to put them back together. Do you guys remember what to do when there's subtraction? You need to put them together somehow. What's the operation I use? It turns to division, so I'm going to have 100 over x plus 1. And that should be equal to 1. So I need to combine my logs. And now that I've combined my logs, I'm going to exponentiate based on the base that I'm already given, which is 4. So by exponentiating, I'm going to raise both sides of the equation using base 4. 4 to the log base 4 cancels. I'm left with 100 over x plus 1 is equal to 4 to the first power, which is just 4. Right? You guys with me on that? It's kind of a confusing thing, right? Were you with me up to here where we put them together using division? So this is a step that we did in 7.4 at the top, so I'm going to just slide this in here. Whenever we had two logarithmic expressions that are being added or subtracted, we had to put them together by dividing those numbers. So we're doing the same thing here. We're putting our logs back together. Whenever we have two logs, we're going to put them together either using division or multiplication based on what we're given. And then to get rid of the log, we don't know how to solve logs, so let's get rid of that by exponentiating. So remember, log base 4 is the opposite of doing an exponential with base 4, so that's why we had to exponentiate both sides in order to cancel out that log. So if we exponentiate this side, we were just left with 100 over x plus 1. I exponentiate this side, and 4 to the first power just gives me 4. Once I get to this point, this is a little confusing. Solving for x, when x is in the denominator, you got to get it out of the denominator. So what I'm going to do is I'm going to take my x plus 1, and I'm going to multiply both sides of my equation by x plus 1 to get that out of the denominator. So here I'm going to get 100 is equal to 4 times x plus 1, which is going to give me 4x plus 4. And this you know how to solve. Once it gets to the algebraic expression that's linear, we can solve this, right? We're going to subtract the 4 to get 4x equals 96, and then divide by 4. Once again, the big idea is to exponentiate to get rid of that log. Once we get rid of that log, we're going to solve for x. This is one of the funky versions where the variable was in the denominator. We had to get it out. So that was example number 2. We're going to do a third example, though. In order to solve a logarithm, you really shouldn't have a logarithm and an exponent within that logarithm. Do you remember what we do with this 4? It's got to come out front. And the cool thing about when we do that is if we have that 4 out front, couldn't we just divide it out? To get 2, right? Isn't that kind of nifty? And I'll tell you, it is really smart to move this out front, because trying to solve something that's x to the 4th power, you're not going to want to do quartic roots. That's terrible. You're going to want to bring that number out front and divide it out. It will make your life way easier. So now I get to exponentiate to get rid of the log. 5 to the log base 5 power cancels. So I'm just left with an x over here. And then 5 squared gives me 25. That was example 3. And here, these last 4, they're kind of all mixed in. So you can see some logarithmic examples, and then you're going to see an exponential in here as well. So remember, on a quiz or a test, they might, like, the order might not follow exactly specifically in order. So it is good practice. For this question, I need to combine my logs before I can do anything, right? I shouldn't see 2 log expressions in one equation here. So before I combine them, I can't have a number out front when I combine these things, so I need to put this 3 back in its place and then work back again. So when I do that, I'm going to get 3 equals log base 8 plus log of x cubed. And then if you recall, this addition, whenever we're adding logs, to combine them, we have to multiply the 8 and then the x cubed. This is a really tricky example because of putting that 3 back in its place. And then, how do I exponentiate something that doesn't have a base? It's possible. It's base 10. Remember from, it was I think 7.3, that we talked about the common log. If there is no base written, it's automatically a base 10. So what we're going to do is take 10 and exponentiate using base 10. In this case, 10 to the 3rd power gives me 3 zeros, so 1,000. And then my 10 to the log base 10 power cancel, and I'm left with 8x cubed. I'm going to divide by 8. I think you get 125. Okay. And then what number to the 3rd power gives me 125? Yeah. So you have to work backwards and get x equals 5. So hopefully you guys are kind of seeing a pattern here. This question is a good one as well, but what I would do is I would combine my logs, right? I'm going to combine my logs, but before I do that, I need to put the 2 back. I can't have that 2 out front, so I got to put that 2 back. And now I can smush my logs together. When I start with subtraction, this turns to division. So I'll get log of x squared divided by 4 equals 0. Oops. I said it correctly, and I wrote it backwards. And then, there is no base. I need to exponentiate using base 10. Log of base 10 and exponentiating with base 10 cancel. So I'm left with x squared over 4 equals, anything to the 0th power is 1. And when I solve this, to get x by itself, I multiply both sides by 4. And then in order to undo a squared, I'd have to square root to get x equals plus or minus 2. Why do I have a plus or minus? Whenever you square root both sides of an equation, you should put a plus or minus. Will I be picky about that? Probably not. Here, instead of starting with logarithms like we have been the last 4 or 5 examples, we're starting with exponentials again. Remember, the first thing you should try to do is get your bases to match. And then if you can't, that's when you can use the calculator way, right? But first and foremost, I know 2 goes into 2 and 2 also goes into 4. So we have 2 to the x power, and then 4 is equal to 2 squared, correct? And then I have an x minus 1. Once I get to this point, the rule of power of a power means I have to multiply my exponents, but when I do that, I have to multiply both pieces by 2. To get 2 to the x power equals 2 to the 2x minus 2. Correct? Okay, I want to make sure I distributed correctly this time. When I do that, I should get x equals 2x minus 2. And to solve that, I'd subtract 2x from both sides to get negative x equals negative 2. And then divide by negative 1 to get x equals 2. So this is called change of base. So we changed our bases to match, and then we used exponent rules to solve, right? What about this guy? What should be my first step? I see a logarithm and I see an exponent within that logarithm. So usually what we do with that is we bring it out front, right? Once it's out front, the really cool thing is we could just divide it out. Now we have log of x is equal to 3, so I can exponentiate using base 10 to get rid of the log in the base 10, and here I'm left with x is equal to 10 to the third power, which gives me 1,000. Right? So a lot of different types of examples. Remember, most of the exponential problems are up here, so when you get to your homework, you're probably going to be hanging out up here for all the ones that start exponential, and then for the most part down here for the ones that are logarithms, all right?